Gas chromatography is an excellent tool to quantify reactants and products in a chemical reaction. It is useful to calculate the yield and change in concentration of reactants and products with time. In this video we will know how to calculate the GC yield. This is the GC chromatogram. When you inject sample into GC, it will give you similar peaks. And the number of peaks depends on the number of volatile compounds present in your sample. Here, the x-axis is time, that indicates how long it takes for a particular compound to reach near the detector. It depends on the polarity and boiling point of the compound. And the y-axis represents the response, which is basically the voltage. The entire area of the peak represents the amount of the particular compound. We shall see how we are going to convert this area into the true concentration of the analyte. First, you must understand that GC does not know the identity or nature of the compound being injected. It only detects a response generated when the analyte reaches the detector, such as an electrical signal or a change in thermal conductivity, depending on the type of detector used. Each compound can have a different detector response. For example, if equal amounts of two different compounds are injected into a GC, they may produce peaks with different areas. This occurs because the detector has different sensitivities toward different compounds. So it is difficult to say the exact concentration of a compound in a reaction mixture by seeing the area. But there is a way to estimate it. It can be done by using an internal standard or external standard. Internal standard is a compound which concentration is known in the sample mixture. Any volatile compound can be used as internal standard, provided that its peak does not overlap with the peak of any other compound present in the mixture. Suppose you have reaction of benzyl bromide with NaOH to form benzyl alcohol. Now, your job is to calculate the amount of benzyl alcohol present in the reaction mixture using GC. We will see how we will do it using stepwise manner. First, inject the pure benzyl alcohol under a fixed GC heating profile and observe its retention time. Here, we can see benzyl alcohol comes at 10.31 minutes. Now we will have to choose the internal standard. We know our reaction mixture may contains some benzyl bromide too. So we will have to select the internal standard which peak does not overlap with either benzyl bromide or benzyl alcohol. In this case we can choose n-decane as the internal standard. Here, I have shown a GC chromatogram of a mixture containing benzyl bromide, benzyl alcohol and n-decane. You can find all peaks to be distinct. The retention time of benzyl bromide, benzyl alcohol and n-decane are at 5.98, 10.40 and 18.72 minutes respectively. In this way, we have selected our internal standard. Now, we will plot a calibration curve. In order to plot a calibration curve for benzyl alcohol and n-decane, we have to prepare at least 5 numbers of samples containing known amount of the two analytes. Here, we have 5 different samples. Each sample contains 2 ml of solvent. In each sample, we have added 1 millimole of internal standard, which is n-decane. Now, in sample 1, we added 0.5 millimole of benzyl alcohol. In sample 2, we have added 1 millimole. In sample 3, it is 1.5 millimole. In sample 4, it is 2 millimole. And in sample 5, it is 2.5 millimole. Then, inject each sample into the GC and observe the area of each analyte in every injection. Here is the snap of each chromatograms. For each peak, note down the area. Now plot a graph using the ratio of area of benzyl alcohol and n-decane along x-axis versus ratio number of moles of benzyl alcohol and n-decane in y-axis. Allow the line to pass through 0. Now, the slope will give you the calibration constant and will be used for the estimation of concentration of benzyl alcohol in unknown solution. Here, the slope is 0.6678. It follows the linearity equation, which is y is equal to mx plus c. Here, c is equal to 0. Basically it says, ratio of number of moles of benzyl alcohol and n-decane is equal to the ratio of area of benzyl alcohol and n-decane into the calibration constant. So, for a solution containing unknown amount of benzyl alcohol and known amount of internal standard, when injected into GC, we will get the corresponding areas. Now using the calibration constant, we can find out the number of moles of benzyl alcohol present in that solution using this equation. To summarize, first identify the retention time. Choose a suitable internal standard. Plot the calibration curve and obtain the constant. Add known amount of internal standard to the reaction mixture and inject to the GC. Obtain the area of internal standard and analyte. Finally, calculate the unknown concentration of analyte.